Welcome everyone here. So we are gonna start again for our new round of sessions. We are gonna welcome Professor Sungwon from Roosevelt University and Fang from Georgia State University. They will talk about integrating real-world data into actual science teaching examples and challenges. And actually, there will be another talk by both of them after this. So if you are interested, don't forget to join us in the next session as well. Thank you.
Thank you, Ma. Thanks for introducing our talk. So, before I begin about showing you the example, let me just briefly talk about the rising interest in the data analysis in the actuarial science. So the demand for the actuaries skilled in data analytics has increased. This is true because there are a lot of more and more data are available and collect. So the companies, the insurance companies or any risk management company, they want the actuaries who can handle the big data. So in order to meet this demand, the Society of Actuaries, that's an organization of the actuaries, they established the predictive analytic certification program. And those who complete this program, they receive a credential on that. And also, the SOA, they starting to create this data science symposiums on the predictive analytics. And also, most importantly, they create these 3 data analytic exams, which I can discuss that after in the next presentation. And many universities have launched actuarial science programs within their math department and updated their curriculum to incorporate this data analysis. And so I and Fang, in order to develop the program to teach this data analytics, we created these 2 courses, and one is the case study with the industrial partner that is done by me, and I will talk about one example about how I conducted this class. And later on, Professor Fang will talk about the senior actuarial science capstone courses. Both of them handles the real data so that students have more interest and students are aware that they're actually handling the real data and study that and use the actuarial science techniques or subject to analyze the data. So this is my part of the presentation. It's a case study with an industrial partner. Before I talk about the whole flow, here are the pictures where I invited one of the data analytics experts and giving him the case study, actually making him to make the case study and provide the case study to the students and work together. And this is another picture of my student and the case study provider. So this example is called the predict bank revenue for the stress test. And the bank stress test is it checks how well a bank can handle tough economic times like recessions, because like these banks are vulnerable to the any loss from the financial difficult times. And this bank stress test help them to maintain their solvency or financial stability in their operation. And in order to do this bank stress test, the prior step to do it is to estimate the pre-provision net revenue. And this is the basically calculating the how much money the bank makes before setting the fund aside for any potential loss. And it's basically the difference between the income over the expense from the bank. And the goal is to find the key economic factors that affect the bank's revenue and predict the PPNR and suggest any improvement based on the result. So here is the steps. It's a monthly, month length, not month, the semester length case study. And my school and or my class, we open this case study course every fall. And first they study the regression or the time series modelings for the first 6 or 7 weeks, and then they go over the literature review, and then write the proposal on the modeling, and then using that proposal, they actually implement that model and do the analysis. So the initial preparation is starting with finding the case study provider. I found the provider from the case career fairs, or we have our own actuarial advisory board, and also or the conference or symposiums. And we have an initial meeting, and we share I tell them the class schedule and the level of the students' understanding on the data analysis and things like that. And then during the first 6 or 7 weeks, I make sure that students have enough knowledge on the regression or time series, and I teach them and give them some homeworks and exams, things like that. And then the case study provider comes at this time, this is we did this in 2022 when there was a high inflation. We have another high inflation this year, but it was we had a very high inflation in 2022, and the bank stress test was kind of crucial at that time during that high inflation time. So the case study provider, he introduced this stress test called a Dodd-Frank Act stress test. And all this reports and data set is available in the Federal Reserve Bank or Federal Reserve site. If you go into this Federal Reserve site, there are 2 parts. First is the scenario, and second is the methodology. The scenario have a bunch of data, the historical data plus the future data based on the several different scenarios, a good economic condition, moderate and bad economic condition. And the second part is the methodology, where it tells you all the details about the key terms and the modeling equation of the PPNR, and also the entire process of the stress test. PPNR is just one chapter or one section of the stress test. And then we collect actually this one was given by the case study provider, but you can also find this data from the publicly available public website. If you can find this data from the annual report in the bank, and also not just annual report, but the quarterly report. So in the second step, after introducing all these tools and do the literature review, we ask students to write a proposal, the development proposal. And well, during this time, the instructor and the case study provider, we do the brainstorming with the student and lead them to make a correct model. Okay. This is the most important process, because if they don't make a right model, then they're going into the wrong direction afterward. That's kind of wasting time, and it is good. It is very important to start with the right model. So at this time, we ask them to design a model of the three factors: the interest income and the non-interest income and the interest expense. And all the groups decided to do the regression. And this regression and do the variance reduction modeling, so that they find the key factors that generate those three different incomes and expenses. And then using that key factors, they can calculate the PPNR, the future PPNR. I told you that in the website, there is also the future data based on the scenario, and use those future data to calculate the PPNR. And here is the result, one of the result from one of the groups. And it is very, the student had very fun with this project, because this is the real work, and this is what they will do when they go into the financial industry or actuarial science industry. So they were happy about doing this work. And I let the Fang do this next one, which is a senior capstone.
Okay, thanks everyone to be here. So Sungwon already shared his part of the partner with industry partners. I'm going to sharing the capstone course I've been doing with my students. So the capstone course is a year-long students project course there. So there are a couple of steps. So the first thing is you have to know, the first thing you have to know the students, I don't know. Okay, the first thing you have to know what students need, what the interesting are. So you talk the topic with students. After you did, I assign students readings and exploring the data sets, then modeling, then assessment. So I'm gonna follow the slow here. So the project topic discussion is a very important step, because this is the one you know what idea students really interested in and what they kind of want to pursue. Back here. So the background is initial reading assigned for students is this project is by the Pareto distribution. So students really interested in exploring different distributions on the loss model. So I assigned the reading is distribution for actuaries by David, and also reinventing Pareto. So this fits for small and large losses. So students get a sense of what Pareto distributions are, what's the special thing about that, why, in the actuarial science world, we're using Pareto distribution to modeling the loss, extreme cases there. So expectation for students is I would like them to understand the characteristics, applications of Pareto distributions, and why we're using it to model high-risk insurance claims, and how do we, perform, and how do we measure the model accuracy. So the students' advanced reading is student has to understand the difference between the single Pareto and the two Pareto distribution. So there are two different Pareto distributions. So students, we most often commonly use the two parameter Pareto distributions. So after students review the literature, they'll be able to understand, the Pareto distribution is very flexible and commonly have very heavy tail. So like log and normal distribution is that's why it's very adept to fit income data or any social economic data. So this is a graph, students graph it after they kind of change the alpha, the parameters which is the share parameter to know what's going on, with this kind of distributions. So the real data set is, it takes a little bit of time for students to explore the real data set. So after this couple of meetings, regular meetings, students actually come back, I think a month later, and told me he is very excited, said, oh, I did find the data actually. He want to use this NPDB, is National Practitioner Data Bank. The data actually track the performance of healthcare providers and practitioners, documenting any history of a malpractice. So this data is a public use data, so you can find out the amount of dollars, the claim size. So it's really, really good data there. So this is the one students choose to using the Maryland for 2012 data. The students come from the state of Maryland. He's interested in using the home state data. So he gave us the aggregate data with amount of millions on the left column and the number of claims in the middle column. Right side of column give you cost of claims and millions dollars. So after students play around, you can see the data on the score, high cost claim, they only have a few, like, one number of claims, right? But they have like a 785 million cost, the payout cost there. So this kind of give us idea the Pareto distribution is effective for modeling such a data, because they have one big claim actually going to be almost 50% of all the payout there. So also students plot this graph to show the histogram, also the trending of total claim. So we can see the 66 of the 295 claims are greater than 500,000, and those 66 claims only amount to 82 million out of this total amount payout. So which means 22% claim actually accounting for approximately 70% of total payout. So from here, students know this participant should be very good fit to model this, the data, and maybe can see how accurate predictor for the future payout. So the left side show you the fit parameter with alpha and theta. The right side, so the method student use to do the moment matching. So align the sample first and second moments, and with this Pareto distribution, a lower right side shows this graph to see how accurate, fitting with the PDF, with probability density, probability function big F with empirical probability X less than X to see how the accurate is. However, after I talk to students, I do suggesting them to separate the data into training and testing data to see, what's MSE, mean square error for testing data, because we do know the training data is not good way to see how good the model is. The testing data MSE is going to be much credible, the rule of the measurement to test the model accuracy. I also suggesting some other tests, student can conform, also can, using AIC, BIC, also maybe try like normal distribution to see how that goes with different models, comparison with different measurement, quality fit, kind of measurements there. So the feedback from students is they said, the project has really helped students land internship and jobs in many ways. It's great talking point during the interviews, and working on projects actually helps them more familiar with the real world application of actual science. Another student said the project is a way to show employers that you have skills such as project management, problem solving, and communications. So this is just two of the feedbacks I put on here, because that's not much room. We can put a lot of feedbacks there, but I do think students really appreciate opportunity to do the project here. However, this is kind of summary of me and my co-author doing this kind of experiential learning, there's a lot of challenges for doing such, the work incorporated into your teaching. First of all, is constraints and resource. You had to be able to find the time. There's a lot of time you had to put in. I mean, especially for capstone, you had to be able to meet students individually, and also the public data may not be available, and that's kind of take a long, or maybe the data had to be purchased, which is financial way may not be possible for students and also the faculty. For Sungwon's case study, you had to find somebody, be willing to work with, faculty to develop case study. Our recommendation is, maybe you can, if you cannot find the public available data, the Kaggle is one credible data sets. We can, I do suggest, if you're interested in teaching or doing any data analysis, you can go there, find some data sets. Navigating any career fairs or a conference, meet people who are willing to do kind of work together. SOI or CS have some big annual meetings. Faculty can go there and, meet people who are willing to, energy or passionate, with helping with the next generation students. Also expectation gap is, for CAS providers, they don't know what exactly your students' level are. They may develop projects at a very high level or may not be, suitable for students. So you had to be able to tell them, what's kind of your, you're going to be the middleman and try to make sure the project is doable within the time frame during the semester, and also it's going to be exciting for your students as well. Okay, so also the time management, still sometimes students don't do the project until last minute. So you really want to make sure you give them timeline to check each step, make sure they're moving along, and host a Q&A, during the semester. Don't wait till last, the week, so that'd be too late. Provide regular feedback, and normally, I think a teamwork will be much nicely than individual work, because students more likely to work with the teams better. Also create a clear rubrics. Students know what they're looking for, how to be measured when they finish up. So we hope to provide any guidance for this child who seek similar, very similar teaching tools for their actual science courses. And we just, our experience say, this requires significant amount of time, effort to prepare the project. So we are happy to help. If anybody interested in here, definitely reach out. And I think it's worth it to show, we try to adapt in the changing world of, actuarial science, and also, with the world changing with AI. So I think as a faculty, we want to, prepare students for the real world while they are in the college. So this is the reference we have, and any questions you may have at this point.